Good morning, everybody. Thanks for coming to talk today about the art of inventing things. This is a new subject for me. I'm never going to talk on this topic, and actually I think you'll find it's got some interesting thoughts in it. The first thing is that I think you need to think about an inventor as being an artist. Conceiving a new invention or having a vision for what kind of a solution there might be to a particular problem requires great use of what they call in patent law the creative faculties. And creativity is defined as the ability to transcend traditional ideas, rules, patterns, relationships, and the like, and create meaningful new ideas, forms, methods, interpretations, etc. It's the ability to be original, progressive, or imaginative. And I think that this well describes the inventor. I had an inventor when I was at the University of Virginia who she'd made many inventions. She used to describe herself as a repeat offender. But she had a great deal of creativity in the way she approached the world. And so if you think about it, is Edison's light bulb any less creative than Mozart's Fifth Symphony? Edison didn't actually invent the light bulb, but light bulbs back at the time would last about 25 seconds. They weren't very useful. And what Edison discovered was the way to make actually he had a piece of bamboo coated in carbon that was held between two wires, and that was the filament. And he also learned to use an improved vacuum inside the bulb so that the bamboo wouldn't deteriorate. And that was really the basis for his invention. There's actually an Edison light bulb that was made by Thomas Edison's original company that is still burning in a Chicago firehouse. Over 100 years, it's been burning continuously. And I think that's every bit as cool as Mozart's Fifth Symphony. Eli Whitney, of course, invented the cotton gin, which revolutionized the farming of cotton and the harvesting of cotton that used to be done completely by hand. And he had an enormous impact on the textile industry in its day. Is that any less creative than Picasso's self-portrait? I don't think so. I think it's every bit as creative. But how do you learn inventing? Well, surely Mozart had to learn how to read music, and Picasso had to learn to draw and paint. And there are some things that, as an inventor, that you can learn that will help you to become a better, more skilled, and more prolific inventor. And if you, just like an aspiring artist, it's going to take time and effort to get to the point where you can put those tools to use. But the effort can be quite rewarding. So we're going to talk about how do you go about becoming a great inventor. And what I suggest is that you first learn about the legendary inventors, make patents part of your everyday world, treat what is known with a high degree of irreverence, cultivate an open and curious mind, consider strange and unusual combinations, play around with ideas and things, doggedly follow questions, doubts, and hunches, make questions and problems bigger than they seem to be, and ask for help from people who know nothing about your invention. And lastly, believe in your own creative vision. We're going to talk about these and talk about how you can do these. Now, the legendary inventors are easy to learn about. There's a National Inventors Hall of Fame that has many of the great inventors through history in it. And they give short descriptions of those, their inventions and those people. And once you know their names and what their inventions were, you can look elsewhere on the web and get a lot of information about what led to their invention. How did they come up with that idea? Because it's just like Mozart had to learn about the great composers. Learning about great inventors will help you kind of see where they were when they came up with their great ideas and get some insight into how they turned the corner. So, for example, Edison didn't set out to actually invent the phonograph. He was a telegraph operator, and he thought it was too slow to send telegraph messages by hand. And he thought, how about if you had a machine where you take a drum and you put holes and scratches where you have the dits and dots, and then you just turn the crank and it will send the message, and it can send it much faster than you can key it by hand. And so that's what he made. And when he turned the crank, it made a melodious sound. And he said, wow, this sounds almost like music. I wonder if you could use this to somehow put music on it. And that's what got him. So he had no intentions of developing the phonograph. He was trying to invent something completely different. This light bulb, however, came from an enormous process of trial and error to find a better filament material, and make ways to make a light bulb last longer. Actually, there's one other thing that Thomas Edison is famous for inventing, probably his greatest invention ever, and that is he invented research and development. Corporate research and development was unknown in his day. And he was such a successful inventor that he decided that people, if he brought in engineers and chemists, that he could put them to work on projects to invent things. And that's exactly what he did. The Wright brothers flying machine, the only reason the Wright brothers were successful in developing the airplane was they decided from the outset, they started studying what was known about flight from what other people had written, and they decided that it was all inconsistent and they should just throw it all out and start from scratch. So they went back to studying birds and studying the architecture of a bird's wing to try to figure out why it was that a bird was able to fly. And that's how they came up with the airfoil design that, of course, made all the difference. Chester Carlson was a patent lawyer, and he hated carbon copies. None of you probably even remember carbon copies, where you had a piece of carbon paper and you would write on the top sheet, and it would transfer the carbon image on the sheet underneath. But you had to file the original typed document with the patent office. And he hated to have to read carbon copies in his files. So he tried a whole bunch of things. He tried having them photographed. Well, that was too expensive and they faded too quickly. He, for a while, paid his secretary to type 2 originals, which was very expensive. And luckily, Chester Carlson didn't know anything about the wet chemical process of photography. If he had, he would have gone down a dead end like many others had. Instead, he was an electrochemist, and that's why he came up with an electrochemical solution to how to make photocopies. Carlson's, the invention of the copy machine is also a great story because he went to every company that sold business equipment in the United States, and they all told him, who's going to buy a machine that makes copies? Carbon paper is a penny a sheet. You can use it like 5 times. And he finally found a guy who owned the Haloid Photographic Paper Company, who was willing to invest in building the first copy machine. And when that you could just push a button and a copy would come out, and absolutely nobody bought one. And the guy who owned the paper company said, well, if I could just get people to try it. I mean, I've had one in my office. I can send copies of things to all my employees. He said, if I could just get them to try it. So he put a meter in the machines, and he rented them. And he said, I'll just charge you by the page. And the rest, as they say, is history. So you need to, if you study the stories of the great inventors, they very often made their inventions by stumbling, experimenting. Many inventions were come upon simply by accident, but people realized that it was a great accident. bad scientific results, and people realize, well, wait, this isn't telling me what I thought it would tell me, but it's telling me something that I don't understand. Let me figure out what this is telling me. And their stories will help you to sharpen your thinking about how inventions might be made. There are living legends too. So there are some great inventors who are still alive. Some of them go out and give talks. If you can ever get to go hear great inventors talk about how they made their invention, it's very interesting. I had occasion to meet the guy who invented the Rolo grill. Anybody know what a Rolo grill is? You see them in every 7-Eleven. It's the hot bars that cook the hot dogs. And he told his story about how he invented it. He built a company, became very successful. He sold the company, made a lot of money. And he made another invention, spent every dime he had trying to make that invention a success, and utterly failed. But there are lots of great inventors in biotechnology as well, and these are ones that you might want to pay particular attention to. So Leroy Hood invented the DNA sequencer. When I was in graduate school, DNA sequencing was something you poured your gels yourself, and you pipetted the samples onto the top of the gels, and we were absolutely thrilled if we could sequence 1,000 bases a week. Just think about what the DNA sequencer has done. Well, there's a story behind how Leroy Hood invented this, and this is something that might inspire you. Alec Jeffreys invented DNA fingerprinting, and he did so quite by accident. He just happened to have samples from two relatives that he happened to be testing, and he realized that he got very similar DNA patterns from those two related people. And he said, wow, I wonder if you could use this as a means of identification. Kary Mullis invented PCR. And Kary Mullis's invention of PCR, he says, was completely by accident. He was actually thinking about a completely different problem that he was trying to solve in the laboratory. And although I don't recommend it, he says that he came up with the idea of PCR when he was driving through the winding mountain roads in California high on mescaline. He's a very colorful character. He won the Nobel Prize for PCR. And when somebody asked him, what are you going to do with the $1 million prize? He said, I'm going to spend it on surfing and women. And he did. Herb Boyer and Stan Cohen invented gene cloning. Of course, gene cloning had an absolutely revolutionary impact on all of your lives. And it was because these two guys came up with it. And actually, as the story goes, they had published this, and it turned out to be very exciting. And the tech transfer guy at Stanford said, we got to patent this thing. And they're like, patent? Oh, patent. And they ended up filing a patent application on the very last day they possibly could. And that patent was licensed by Stanford to many companies, and they basically allowed universities to use it for free. And it was a substantial source of income to support research at Stanford and at Caltech. Luc Montagnier and Robert Gallo invented the first diagnostic test for HIV. In fact, they are also credited with having discovered that AIDS was caused by the human immunodeficiency virus. And needless to say, it was only once there was a diagnostic test for HIV that they could start to understand its transmission and also find ways to block its spread through the community. Maurice Ralph Hillerman developed the hepatitis B vaccine, which of course has been enormously important in treating what otherwise was a debilitating disease or preventing it. So learn about the great inventors, study their stories, find out what is it about the way these people thought that led them to make great inventions. And one of the things that led them to make great inventions is making patents part of their world. Now, you couldn't do basic science without reading journals. And you should think about patents in the same way. If you want to be an inventor, you should study patents. If you're interested in inventing things in a particular field, find out what patents there are in that field. And it's very easy to do today. The easiest database to use is probably Google Patents. Give you access to full text copies of every patent that's issued since 1790. The World Intellectual Property Organization says that 70% of the world's technology is described only in patents and is not described at all in the academic literature. So if you're not looking at patents, you're missing out on a big part of the science that really could be part of your world, particularly if you'd like to invent things that will advance the field in special ways. Reading patents is an acquired taste. When you read scientific journal articles, they take all this data and then they boil it down to the one most highly supported conclusion from that entire set of experiments. When they write patents, they do exactly the opposite. They take the data and they extrapolate it as broadly as they possibly can as to how it might be applied in the real world. Patents have very, very defined parts. There is the written description generally begins with a background section. It talks about what the problem is that they're trying to solve. May talk a bit about other methods of addressing that problem that have been patented in the past. And then it'll give a brief summary of the invention, and then it'll give a detailed description of the invention and referring to figures that illustrate how the invention works. And then at the end, they're called examples, example 1, example 2, but they're a little bit strangely called that because they tend to be not examples of the whole invention, but they're examples of part. So here's how you make the gene construct, and then here's how you insert it into the cells, and then here's how you express it. So there will be 3 examples, which seems kind of a strange way to phrase it, but that's what it is. And then at the end of the patent, there are the claims. And the claims are these numbered statements that define the metes and bounds of the invention. And the wording of the claims has very deep historical roots. So I usually start out with something like a method of making this gene construct comprising the steps of A, B, C, and D. Well, that means the word comprising means including at least. So you could have a process that has 40 steps, but if it includes those 4, it's covered by the patent. And there are various kinds of claims. There are claims to devices and machines, and they're usually the easiest ones to understand because they have these drawings that kind of illustrate the invention. So start with reading some simple mechanical patents like sports equipment. I like snowshoeing. I looked up snowshoe patents, and there's all kinds of patents on the bindings and on the things that help you from sliding backwards down the hill, the crampons. And so kind of look at something simple like that that's kind of interest to you. That will help you kind of get the feel for how patents read. And then you can move into things that are a little bit more complicated. You can actually patent recipes. So I don't know if you all remember when Nabisco came out with the soft batch Toll House cookies, where you take them out of the package and they're kind of soft like the cookies when they come right out of the oven. They had a patent on that, and it was the subject of one of the greatest patent lawsuits in recent history. Biotech and pharmaceutical patents are a bit tougher. if you look for a patent that's very closely related to your research, and you can do that just by keyword searching, then you'll be able to understand it a little bit easier. They often contain long, boring section of basic biochemistry and definitions that because of certain court decisions, people feel compelled to include. So there's a definition of what nucleic acids are and blah, blah, blah. So you can kind of skip over those parts. The wording can be a little bit obtuse. Some particularly older patents you'll see where it will say, said cross member then is attached to said wheel, which is attached to said sprocket. Said just means the. And it's kind of an archaic style, but you still see it in a lot of patents. Chemical claims, for example, on drugs, very often you'll have just a core structure, and then you have R1, R2, R3, R4. And then it'll say R1 is selected from the group consisting of methyl, ethyl, butyl, propyl, and sulfide. And so you think about the scope of a claim like that. You could probably draw a 50 and when you've got 4 R groups and each one has a set of things that it can be, you could probably draw out 15 pages of structures that would be covered by that one claim, which of course makes it very valuable. And drug companies write such claims and get such patents so that people can't make fairly logical modifications to their molecule and avoid the scope of the patent. Anything that has protein or nucleic acid claims, they have to include sequence listings, some of which can be quite extensive. And they're referred to often in the claims just by sequence number 1, sequence number 2. And the sequence listings are all today filed electronically with the Patent Office. And the Patent Office, one of the first things they do when they have claims that refer to sequences, they'll search to see if the sequences are known, which today, any basic gene structure is known because of the Human Genome Project. But there are many, of course, variations that you can make. Another thing you want to do is, when you think about what is known about how certain things are done, treat it with some irreverence. Don't assume that that's the perfect way to do it. You're all sitting in chairs. Is that necessarily the best chair ever made? If you look, you go to Staples and you look at all the different chairs that are there. Many of them are patented because people have said, there's a better way to make a chair. There's a better way to make a chair more comfortable, more ergonomically functional, and ways to make them cheaper or stronger or more stable. So just because there was a great invention doesn't mean that you can't make an invention that would be even better. So even if you look at something that you think is pretty settled, like PCR, well, just because PCR works and it's handy and you kind of got used to using it doesn't mean that's the only way you could do that. So if you think about it, the pencil, I'm sure, was the first writing tool, and basically a piece of charcoal wrapped in something to keep your hands clean. And you look at all the different writing tools that have been invented since then. I mean, the felt tip marker probably came around in the 60s. And now they have very fine point felt markers. Some of you may be old enough to remember when I think it was Cross Pens came out with a ballpoint pen that would write upside down, because they invented it for the moon launch, because they had to be able to use a pen in zero gravity. Brilliant people can miss very simple solutions to things. One of the things I noticed in the stores the other day was there's one of these Greek yogurts that has a container that has a big section and a small section, and the small section has the fruit in it, and the big section has the yogurt. And the small section is just the right size. You can stick a spoon in there and flip the fruit into the yogurt, and it tastes a lot fresher that way. Very simple solution. One of the great inventions that you take for granted today, the flip-top lid. Some of you may remember when every soda can had a pull tab that pulled off when you opened it, and the big concern was that they were getting into streams and fish were eating them, and they looked like lures, and they were kind of sharp and not too safe for kids to handle. A lot of really clever engineering went into the flip-top can. These aluminum cans are really fascinating too. If you look at the way they're made, there's almost no aluminum in them. And there are many patents on how to make them thinner and thinner and thinner and thinner, yet retain their structural integrity. If you try, sometimes one way you can do it is try to think about something that's known and assume in your imagination that that is no longer possible. What could you do instead? And that's often a great way to come up with an invention. So if you say, well, something I use every day in my research, what if that was no longer available? What would I do? Is there another way that you could accomplish the same thing by a different path? And we talked about making patents part of your world. The Supreme Court says that one of the main purposes of the patent system is to encourage people to invent around other people's patents. So if you find a patent that's related to a technology that either you know or that you're interested in, take a look at that patent and say, okay, well, I see how they solved the problem, and I read the claims and I see what's covered. What could I change? What could I do differently that would allow me to have an invention that's not covered by their patent, but solves the same problem perhaps in a better way? Cultivate an open and curious mind. Now, this is something I had to look up, and actually there's a website called WikiHow, and wikihow.com has a section on exercising an open mind, and they had some good suggestions. They said, listen to music that you don't really like. Visit random art galleries, not just art galleries that were things that that would interest you, but visit ones that are things that you don't think you'd be interested in. You know what kind of movies you usually like. Don't watch those. Watch movies that are of a kind that you don't usually watch. Join clubs about things that you don't know anything about. Build ridiculous things. Anybody know what a trebuchet is? It's a very powerful kind of catapult for throwing things, and they use them for throwing pumpkins and things like that. But tinkering with, some of you may, when you were kids, had an erector set, and you could build all kinds of little things out of steel nuts and bolts. Learn to juggle. Anything to get you outside of your ordinary routine. Play chess or the Oriental game Go, which is a very similar thing. And also, just invent random stuff. When you're standing in the shower, think, okay, what could I invent that would be an improvement over that shower head or that soap dish or this razor I'm using? If you think about inventing more often and think about crazy inventions, some of them may turn out, you may come back and say, hey, you know what, that's not so crazy. And you may be onto something, but it will help you to cultivate an open and curious mind, because when you come back to the lab, you'll end up doing the same thing. Well, how come I do it this way? Is there a better way to do it? And when you're when you're thinking about your science, your technology, and things that you'd like to try to invent, consider strange and unusual combinations. Many great inventions come from creating what the patent, or combining what the patent office calls non-analogous arts. And probably the greatest one of those is in 1450, Gutenberg combined a coin punch with a wine press and invented the printing press. And avoid the obvious combinations. So not peanut butter and jelly. How about peanut butter and concrete? Why would you combine peanut butter with concrete? I don't know. But when you're thinking about solving a problem, don't just reach for the thing that anybody would reach for. Reach for something that nobody would reach for. And that's the creative spark, the creative genius. If you think that there might be a non-analogous field, for example, there was a very famous patent on the lenses that go on your taillights on your car. And they have actually are very similar to the Fresnel lenses that are used in lighthouses. And the patent office said, well, yes, that's also a known way of transmitting light. But people who are skilled in designing automotive parts are not necessarily skilled in designing lighthouses. So that's a non-analogous art, and a combination of the need to make taillights brighter with the idea of the Fresnel lens from a lighthouse is unique. Practice. Go look for crazy things. Look for crazy combinations. I have my house. I have all these little bins of nuts and bolts and things that I have collected over the years from various projects. And one of the interesting things to do is I'm looking for a bracket of some kind. I'm looking through, well, is there something that I can make work? And you really have to think about it sometimes. So if you go to Home Depot looking for something to make your lunch, if you go to a kitchen store and you look for something to cook your lunch, well, that's easy. Go to Home Depot and find something to cook your lunch. Well, that's a little bit more challenging. It's going to require you to really think, what can I use, And again, reading random patents will expose you to those arts. If you go to Google Patents, they always list 5 or 6 patents on the front page of various random things. I saw a patent the other day, a patent on a way of swinging in a swing. Instead of swinging back and forth this way, it said, pull on one chain and the other and you'll go sideways. They actually got a patent on it. The patent office re-examined the patent and said, this has been known by children for a century, and they canceled the patent. But it's interesting just to read random patents. And there's also, if you go to the Patent and Trademark Office website, there's something called the Guide to Classification, which is very interesting. And they've taken all of the technology in the world and they've divided it up by what it is, because ultimately they have to assign these patent applications to a patent examiner who knows something about this very small niche. I went to the patent office once and I was doing a patent search, and I got the search assistant to help me, and I said, the invention was if you take cookies and you coat them with chocolate, they get soggy. So this inventor, this was a professor at Rutgers, had come up with had something that you could coat the cookie with first and then coat it with chocolate, and the cookie wouldn't get soggy. And so he said, okay, we look in the class of food, we look in the subclass food coatings, we look in the subclass multiple food coatings. Oh, here we are, multiple food coatings where the last coating is chocolate. And there were like 30 patents on that. You can look at the Guide to Classification, or one of the other things you can do is if you find a patent that you think is kind of interesting, if you look in the top corner, it will say the class and subclass that they've put that patent in. Then you can go and do a search for that class number and you'll get a list of all the patents that are in that class, and it'll be all the patents that are similar to that. The Patent and Trademark Office also has a very simple search engine that's very good for doing that kind of thing. The only downside to the Patent Office website is they don't have patents that are before, I think, 1967. So if you're interested in really old patents, Google Patents is much better because you get full text copies all the way back to 1790. Here's a good example of a strange combination. So Microsoft has a spam filter that they're constantly having to, it's kind of like they're in a big battle with the spammers, because every time they find a way to catch things in a spam filter, the spammers find a new way to get around that filter. And so Microsoft said, you know, what we're doing with trying to deal with these ever-changing attempts to defeat our spam filter is not unlike what a virus does when it mutates. And so they went to the Ragon Institute, which is an effort by Harvard, MIT, and Mass General to come up with an HIV vaccine. And they modified the Microsoft software to actually be able to predict the mutations that would occur on the surface of the HIV virus. And using it, they were able to analyze an entire year of data they'd collected in 2 days. And they identified 6 times as many possible attack points for making a virus than were previously known. It's a great example of a combination of completely non-analogous arts, but they had something in common, and that is trying to fight a continuously mutating enemy. Play around with ideas and things. You know, as we grew up, we all gave up playing and started focusing on goals all the time. See if you can go back. Try and be a little bit more playful in the way you think about the world. And this will help to open your creativity. Brainstorming is something that can be very helpful in trying to make inventions. And brainstorming can be even more effective if you all agree in advance that it doesn't matter if your proposal is completely idiotic or insane, you should still say it, because there might be a direction that we didn't think of in that hilarious idea. Tinkering, of course, is a useful kind of play if you're trying to invent something that's a physical device. Tinkering around with it, looking at different possibilities. Not always. If you start out with it being square, it's like, well, what if it was oblong? Or what if it was a rectangle? The Lemelson Center has a great section on his website called invention@play.org, and they actually talk about how important play can be in being a good inventor. Anybody know who Jerome Lemelson is? Jerome Lemelson is probably one of the world's most prolific inventors. He used to describe himself as a science fiction writer for a very limited audience. He only wrote for patent examiners. And back in those days, when you got a patent to issue, the patent was good for 17 years from the date it issued. It didn't matter how long it took to get the patent. So he wrote very futuristic ideas in his patent applications, and it took him 10, 15 years sometimes to get his patent issue. A good example is he had an invention for an automated warehouse where you would have a person at the front that would punch in the order into a computer, and then a robot would go out and grab things off the shelf, bring them back, and put them in a box, and when the order was complete, the robot would seal the box, put a label on it, and stick it in the mail. And the thing is, he wrote this patent application in around 1953. The only computer there was the Univac, which was all vacuum tubes, and it could barely add and subtract. And the examiner says, this is impossible. Nobody can make such a thing. How do you make that we don't even know anything. Robots, that's like science fiction. He said, this will work. I know it'll work. It's just computers are going to come along. They're going to get more and more advanced, be able to give more and more complex instructions. And he kept fighting with the patent examiner for many years until finally a manufacturer actually started selling robotic warehouse equipment. And he sent the patent examiner a copy of their sales literature and said, look, just like I've been telling you for over a decade, this technology is great, it works, it's got value, I'm entitled to my patent. Well, he got his patent, and he got 17 years of patent life after that. Well, people were already using the invention. So he made a great deal of money. He was also frowned upon. These were called submarine patents, that they were kind of lurking beneath the surface, and then all of a sudden, the patent issues just about the time they become extremely valuable. Today, you can't do that because the patent only lasts 20 years from the day you filed your application. But Lemelson made many great inventions, and he endowed a center for inspiring the inventive and creative spirit. Doggedly follow questions, doubts, and hunches. If somebody asks you a crazy question, don't just say, oh, who cares about that? Think about it. When people ask crazy questions, if you can solve crazy questions, very often you make an invention that nobody ever thought of. Take it seriously. If you get an odd experimental result, don't necessarily assume it's bad technique, especially if you get the same bad result twice. Think about it. Why am I getting this result? What is it? You may remember last time I talked about the guy who invented cisplatin. He was looking at the impact of a pulsed electrical current on the proliferation of bacteria. And he found that when you put them in the electric field, that they would no longer be able to divide. And he thought, that's strange. And he didn't really believe it, but that's what he was looking to see. He didn't believe such a dramatic effect. Well, but he continued to pursue it to figure out why. And then what he did was he took the same solution, ran electric current through the solution, and then put that solution into a petri dish, and the cells couldn't divide. Well, now he knew there was some chemical reaction going on. And it turned out that the platinum in the electrodes was combining with some of the buffer components to create this organic platinum compound that turned out to be one of the world's greatest anti-cancer agents because it could stop replication. If you have a hunch that something might work, give it a try. Exhaust the possibilities. If you have a hunch and you try it once, it didn't work. Well, don't give up there. Again, if you get a bad result, don't give up on it. Keep trying to make it work. Exhaust all the possibilities. Try and make questions and problems bigger. There's something called the inventor's paradox. And that is, if you're trying to solve a very specific problem, it can be very difficult to come up with a solution. But if you look at the more general problem, very often you can come up with a solution to the general problem that will also work for the small example. And so this is, for example, this is done all the time in computer programming. Instead of trying to write some small component, you write something that's big and general, and then you hone it in and apply that general solution to the small problem. Many analytical methods are invented this way. So you're trying to do a particular experiment. If you broaden it, you say, well, what if I want to be able to do all such experiments? How could I come up with a way of doing such experiments for any tissue or any cell line or any whatever it is you're measuring? And you very well may find that you can find a solution to that bigger problem. Actually, one of the greatest things to think about. I always encourage people experienced in biochemistry to think about this particular problem. But this is a good example. If you have a particular peptide that you think can have a therapeutic effect, and you can find a way to make it so that you can put it in a pill and people can swallow it and it'll get into the bloodstream, that would be great. But if you can broaden that invention and find a way that you can deliver any peptide drug orally, you will be a trillionaire. It is the number one problem. Is the only blockage between all of the peptide drugs you can ever imagine and the marketplace, because people just don't want to have to go down to the doctor's office or the pharmacy and get an injection 3 times a day, but they don't mind taking a pill. So if you come up with a way to make peptides and proteins survive in the gut and get absorbed into the bloodstream, come see me. We'll make you very rich. Ask for help from those who know nothing. Now, this what seems like is very counterintuitive, but they may know a lot of non-analogous arts. Now, I'm not saying, ask the homeless person on the street. I'm saying ask people who are generally knowledgeable about some field. But if you're working in biochemistry, go talk to a computer programmer. They may be able to understand your problem, but they may have a very different mindset as to how that problem might be solved. Or they might ask you a really dumb question that will lead you in a new direction, because you're not going to ignore those crazy questions, right? They may see it more generally than you. They may not get stuck in the details, and they may be able to help you come up with a more general problem that you can solve. You can get very stuck on what you think are your best ideas. Sometimes you go down and say, I've got this idea, and I've got it so it almost works. And you keep working on that almost work things, and you can do that until you're blue in the face. And what you really need to do is you need to step back and say, okay, let's go a different direction. And sometimes people who don't know about your field or your research can help you do that. Or they may convince you that you've already solved the problem, and you may have a solution for it that got you close that you abandoned, and they'll say, hey, I think you had it, and that can be helpful too. Last but not least, believe in your own creative vision. Never give up. You just have to believe that you can come up with a better answer to the problem than even those legendary inventors who may have come before you. Foraging around in the unknown takes a certain amount of courage, and it takes a certain amount of belief in your own mental abilities and your ability to be creative in ways that other people aren't. We're all unique, and we all come at problems from different directions and in different ways. Some inventions will come to you very fast, some will come very slowly. But if you believe that you've got an invention in you and you're going to find it, you'll keep thinking about it, and eventually it'll come through. So just believing that you have the mental capacity to create new solutions where no solution exists, or better solutions than the ones that are out there, is really, I think, the number one thing that drives people to invent great things. And one last piece of advice. Picasso's first painting, I'm sure, was not his best. Inventing takes practice. And in my experience working with many inventors who've made multiple inventions, they sometimes will be disappointed when the first invention turns out has some impracticalities or cost issues that make it something that companies aren't likely to commercialize. But the most successful inventors are the people who make a habit of it. They no sooner send in one invention disclosure, they're thinking about something else. and they're always thinking about how they can do things better. And the other thing is, once you've gone through the patenting process, you start to get a much better feel for how it all works. And you also, you start hearing back from us about markets and the size of markets and what kind of companies are interested in particular products. You start to get a sense of what the marketplace is looking for and what it takes to get the marketplace to accept something. If you think of yourself as a generalist when it comes to inventing and not just thinking about inventing in the biotech space, you will have a better, you'll get more practice and you have a better chance of coming up with something exciting, whether it's in biotechnology or not. And of course, the greatest example of a prolific inventor was Thomas Edison, who invented a great many things, and you can too. Well, thank you very much. And one other thing I will suggest is don't feel like you have to go through the inventing process all on your own. The Office of Technology Development is here to help you with that process as well. So don't wait until you're certain you've got an invention. Come talk to us when you kind of think you sort of might have one, or when you think you have a problem that you'd like to be able to solve. We can tell you whether that's a problem that the marketplace is trying to solve and for which there would be commercial interest. We can help you get to know what's the closest products to the kind of thing you're thinking about, to help you see how the problem has been solved, to help you think about how to do it differently. There's one of our licensing staff has been assigned to each of your labs, and we're going to make a big effort to try and come out and talk to you on a regular basis. Come in and feel free to chat about inventions or about thoughts you might have about what kind of things you would like to invent. They can give you a lot of insight and perspective. And just to introduce you to some of them, Rachel Mullins in the back. Alina Axanova. And Kieran Rockenstein. And Kathy Falkenhagen is our intern, our graduate student intern. You can also track her down. She's over here all the time. And you can come talk to me. You can send me an email. You can drop by my office. You can see me out in the courtyard. You can come over and, it's true with any of us, come over and say, hey, I was thinking about something. When you talk to us, what you tell us is completely confidential. You don't have to worry about that. Our job is to try and help you capture the value of your inventions, to help support your research and the research institute, and also to help you create a personal reward for your inventions. The inventors get, I think it's 27% of royalty income. So if you make an invention and we're able to find a company to commercialize it, that can turn out to be a fair amount of personal income for your trouble. Anyway, so that's my view of how to go about inventing things. I'd be happy to take any questions you might have. Yeah.
From application to issue, is that a limited time now? Because you were referring to somebody who had a real extended one, but now the decision's made.
Well, actually, the way it works in biotechnology, it's unfortunate that it will often take 3 years for somebody to even read your patent application. But the way the law says that you are guaranteed that the patent process will take no longer than 3 years. So if it takes more than 3 years, then the patent office extends the life of your patent to make up for it. So out of the 20-year term, if you get your 3 year, if you only spend 3 in prosecution, you should still be getting your 17 years. Now that's, so you get adjustments for delay by the patent office. You don't get adjustments for your own delay. So if you drag it out, then that's your concern. But we very rarely have a patent when we license an invention. So once you have filed a patent application, the Supreme Court says that you can license a patent application to a company. It's what they call an inchoate right. Since you filed the patent application, the assumption is you will eventually get a patent. And so if a company licenses your patent application, it'll often take them a few years to start marketing the product anyway. And people will see the patent application. They'll know that companies other than the one that you've licensed to, they're not going to invest in developing a technology that a patent is going to block them from selling. So we often license things very early in the patenting process. Yeah.
Best resource to use for learning how to go through a patent?
For learning how to go through a patent? There's a great book you can find in your local library, or you can find it in your community library, or you can find it on Amazon, called Patent It Yourself by Pressman. And Pressman wrote this book to help independent inventors write and file their own patent applications so they didn't have to spend a lot of money on lawyers. And the book is really helpful in that it's written in layman's terms and it's illustrated with cartoons and things. Makes it fairly pleasant reading. But he goes through describes the entire patent process, describes the parts of the patent, describes how claims are written and what they mean. And so that, I think, is probably the easiest way to jump into the patent world. But the other way to do it is to simply start out by reading some fairly straightforward patents. So simple mechanical patents. You can actually patent articles of clothing if they have functional features. So you'll find things like arm slings and wound dressings and things like that. You'll see patents on. And simple mechanical patents are great because you can refer to the drawings and you can really picture how the invention works. And then when you look at the claims, you can kind of see the relationship with the drawings. So that's a good way to do it too. Well, if there are no other questions, I thank you for coming, and please come and join us for lunch.